Sketch the graph for the modulus of 2x minus 5 on the grid to the right. So let's look for the critical point when the inside is 0, because that is, if it's less than 0, that's when the modulus kicks in. When it's greater than 0, that's when the modulus doesn't do anything. It's going to be 2x equals 5, so x equals 5 over 2, or 2.5. And then what about the y-intercept? When x is 0, we're going to get the modulus of minus 5, which is 5. Okay, on those 2 points, I've got my graph, because it's going to be going like this, and then let me just do that again, then bouncing. Okay, to make sure it looks symmetrical. Solve the inequality modulus of 2x minus 5 less than 1. Right, well, I always solve equations and inequalities using a graphical method, so this is perfect because I'm already set up for it. Because I'm going to be looking at where the graph I've just drawn is going to cross y equals 1. And then I want the modulus graph to be less, so I want it to be lower than the line. So I'm actually looking at this, it's going to be this region here, because like this is it really. It's going to be this interval here. It's going to shade in the whole graph in that part. So if I can find out where they intersect, then I'm there. And therefore, let's solve. Ignore the less than, let's just solve modulus 2x minus 5 equal to 1. The first one is when the modulus isn't going to be doing anything. So 2x minus 5 equals 1, 2x equals 6, x equals 3. Or I get the minus 2x minus 5, because that's when the modulus does kick in. That's going to be this point here, is going to equal 1. So 2x minus 5 is going to equal minus 1. 2x is going to equal 4. X is going to equal 2. And therefore, for my inequality, it's going to be 2 less than x less than 3. Hence, find all the possible integer values n that satisfy this inequality. Okay, all that has happened is that x has been replaced by e to the 0.1, e to the power of 0.1n. So using b, I can write straight away that this e to the power of 0.1n is between 2 and 3. E is like an increasing function. It's not like it's going up and down. I'm allowed to basically take logs of all three things. Log to base e, ln. So I'll get ln 2 is less than 0.1n, because ln of e to 0.1n, I can just bring this down, and then ln e is 1. And that means that n is going to be between 10 ln 2 and 10 ln 3. And then put these in your calculator. It gives 6.931 less than n less than 10.986. So because n has to be an integer, right, well, it can't be 6, but it could be 7, 8, 9, or 10. Hold on.